We are dealing in paper in November 2021, question number 7. Question 7 is on acids and base. Acids and base. So we have Leo section Leo. Question number 7. Sulfuric acid ionizes into 2 steps as follows. Siabona, the first step, it ionizes, it forms that. And then the second step, the ionizer to form this. Now they say 7.1.1, define an acid in terms of Laurie Bronsted. Laurie Bronsted defined the acid as a proton donor. It's any substance that can donate with a proton in a solution. So Laurie Bronsted, but an acid we define iona, it's a proton donor. 2 marks, Leo. Write down the name or formula of the substance that act as an ampholyte in the above equation. EPA act as an ampholyte. Sifuna igama noma formula. Ampholyte yileyo substance that can donate no H+, where we have to accept to H+. It can act as an acid as well as a base. Hence it is known as an ampholyte. So hydrogen sulfate ion, now it's HSO4. It's either you say HSO4 or as a formula, or the name is hydrogen sulfate ion. So that is hydrogen sulfate ion, which acts ion ampholyte. Sesingayixoxela nje ndoba ngayibuzanga sesingayixoxela. Kusho uma HSO4 minus acts as a base, iyamukela HCl, from that it will form H2SO4 bese kwakheka uCl minus. Yabona ke la act as a base, it has accepted H+ from HCl. So it acts as a base. So as a base, asibuzwanga lo mbuzo, ngiyakwenzela nje nawe ujabule ubona uthe uma seko uza kahle. As a base, and then as an acid, then HSO4 minus ingayifaka emanzini, amanzi amukela uH+ abe uH3O+, bese yona iba uSO4 minus. Uma kuyi base, it forms that as a conjugate acid, kanti uma kuyi acid, it forms HSO4 minus as a conjugate base. So this is how that is why Sibiza City, it's an ampholyte. Siyadlula lapho as an ampholyte. 7.1.3 amamaka mangaki awu 3. The conductivity of HSO4 and H2SO4 are compared. Which solution will have a lower conductivity? Mobuga Ka concentration of the acid, i.e. constant of the acid, that is the Kc value acid lapana, itini, it's 1 × 10⁻³ kushukuti minus 2, kandiliana ngaphezulu it's 1 × 10⁻³, which means H2SO4 is released kalula H+. So may release H+, the solution becomes ionized kalula because the Ka value is greater than 1. Then iba ionized kalula. So the conductivity to conduct electricity moving ions is very, very high. Hence HSO4 minus, the conductivity is low. So when you compare the two, HSO4 minus out donate kalula with H+, muyayibona lo Ka value yakhona ingakanani. So I'm explaining the answer. So the one with a lower conductivity, it's HSO4 minus. Yabona ke sesidla ngo HSO4 minus. Uyaqhamuka impela nje uyalunguza. So HSO4 minus has a lower conductivity because its Ka value is less than 1, which means when you compare the Ka value ka HSO4 minus and H2SO4 minus as an H2SO4, the conductivity, the Ka value yaga SO4 minus is lower than that, which means I tend to donate H plus kalula. It does not ionize very easy. It is a ionizer, but not as easy as H2SO4. Hence, HSO4 minus has a lower conductivity than H2SO4. 7.2. The pH of hydrochloric acid is 1,02. So the pH is 1,02. That is the pH of HCl. The pH of HCl is 1,02. Calculate the concentration of HCl solution. So now the concentration. So the pH, if pH is minus log, the concentration of H plus aqueous. That is the pH is minus log the concentration of H plus aqueous. So the concentration of then we know that HCl in water, it forms H plus aqueous and Cl minus aqueous. Sesiyabona ke ukuthi mabethi bafuna the concentration of HCl iyakha H plus water. So once you get H plus concentration ka H plus njengoba iyodwa kusho ukuthi iqhamuka from eyodwa lento. So concentration ka H plus is the same as concentration ka HCl. So asitholeni ke kuqala i-concentration ka H plus. Then concentration of H plus aqueous is equals to 10 to the power minus pH, which is 10 to the power minus 1,02. That is concentration of H plus aqueous. 10 to the power 1,02. Ayisibone ukuthi siyithola kanjani lo 10 to the power 1,02. Ngithola mina the concentration of H plus aqueous is equals to 0.0955 mole per decimeter cubed, or we can say 9,55 times 10 to the power 1 to minus 2 mole per decimeter cubed. So njengoba kuyi concentration ka H plus, now from the equation concentration ka H plus, from this equation concentration ka H plus ilingana na concentration ka HCl. So what is concentration ka HCl? We find that concentration ka HCl it's 9,55 times 10 to the power minus 2 mole per decimeter cubed. So we have that 9,55 times 10 to the power minus 2 mole per decimeter cubed. So we sesitholile concentration ka HCl. Now they say the HCl solution reacts with sodium carbonate. The HCl solution, siyayazi concentration acid, HCl, we have concentration of acid, which is our HCl, it's how much? 0,00 or 0,0955 or 9,55 times 10 to the power minus 2 mole per decimeter cubed. So we have concentration here, Leo acid. Now they say it reacts with sodium carbonate. As it reacts with sodium carbonate, then so a reactor ngale equation according to the following balanced equation. Then 50 cubic centimeter of HCl. Okay, volume of the acid, it's how much? It's 50 cubic centimeter. 50 cubic centimeter of HCl. That is the volume of the acid. 50 cubic centimeter of HCl solution is added is added, okay, is added to volume of the base. Volume of the base, it's how much? It's 25 cubic centimeter of sodium carbonate. So of sodium carbonate, 25 cubic centimeter of concentration of the base. Concentration of the base, sithola ngaki na? Concentration of the base, it's 0.075 mole per cubic decimeter. So we have 0.075 mole per cubic decimeter of sodium carbonate, which is sodium carbonate. So 50 cubic centimeter is added to 0.075 of sodium carbonate. Now they say calculate the concentration of the remaining HCl. What is the excess in the new solution? What is the concentration of the remaining HCl in the new solution? So if we have 50 reacting with 25, I guess what is a concentration of HCl that reacted? Concentration of HCl reacted. Asibone ku reacting ngakanani na, siyathola ukuthi but this solution reacts with, so now that reacted volume of the acid sithole 50 cubic centimeter. Now the number of moles of the acid sathola from the equation 2 moles, and then concentration akesibonde engakanani reactile. Leyo concentration reactile sizominaza yona ulana sibonde nansi esele, the concentration that is in excess, esele in excess. But it's excess, it means into esele mabethi it's uyenza izinto excessively, wenza ngokweqile khona nokusalayo. So volume of the base is 25 cubic centimeter. Then number of moles of base, mangakanani moles from the equation, 1 mole. Then we have concentration of the base, sithola ngaki na? 0.075 mole per cubic decimeter. Now akasebenzisa equation, iphi equation esizoyisebenzisa na? Sithi Na over Nb is equals to CAVA over CB VB. So sifunani CA, sesizothini na? CA is equals to NaCb VB over Nb VA. Is right. Sesinayo CA yilena. What is Na? Na is 2 times CB. CB is 0.075 times what is VB, which is 25. 25 divided by Nb, number of moles of the base, it's how much? Number of moles of the base, it's 1 times volume of the base, it's 50. Sengathi le iyakanye la iyakabili 2 la iyakanye lena. So concentration of the acid is 0.075. Yabona ukuthi maseko ayisekho isidingo sokuthi asenze lesi sibalo asishaye kwi calculator ngoba vele nakho kuyasulana kushiyana kunjalo. So that is the number of moles of the base that reacted. Now in excess kushuthi besina ngaki na? So excess or sesingathi remaining concentration remaining. Sifuna bathi calculate the concentration of excess. All right, so we have the actual concentration of acid excess. This is equals to the actual concentration minus actual minus concentration that reacted. So what is the actual one? It's 0.0955 minus 0.075. What is 0,0955 minus 0.0955 minus 0.075, sitholani na 0,0205. So sitholani SLA concentration 0,0205 mole per cubic decimeter. All right. Now, masibheka lo 0,025. Lo ya 0,025 i-volume yakhona sesingathi V1, which is 50 cubic centimeter. 50 cubic centimeter. Le concentration yakhona okuyi 0,0205. Kanti mase kuhlangene konke sifuna ukuchecka ke concentration yakona konke bathi the concentration of the excess HCl in the new solution u50 plus 20, which is 50 plus 25, sengithi 20 nami sengikhohle uku-add u5 ungazi u5 uthi unebhadi yini. 50 plus 20, the new solution, so we have 75 cubic centimeter. So sifuna ukuthola ukuthi concentration yakhona ingakanani na in the new solution. So then what do we have? Our number of moles are the same ngoba they are in the new solution. Then we say C1 V1 is equals to C2 V2 ngoba then what do we have la? C1 V1 concentration is 0,0205 in 50 is equals to concentration yesibili asiyazi which is how much in the new solution, which is times 75. So sasizothini na 0,0205 times 50 over 75. Over 75. Ake ngenze i-life ibe lula kakhulu for mina. U5 la uya kayi-10, u5 la uya kayi-15. U5 la uya kayi-10, yes lana uya kayi-15. Yeah. U5 la futhi ubuye uye ka2 lana uye ka3. So 0,0205 times 2 sengiyayazi so kuba neshow nje times 2, that is 0,041 divide by 3 I get something like 0,0137. So concentration yakhona will be 0,0137 mole per decimeter cubed. So this is 0,0137 mole per decimeter cubed. That is the concentration of the excess HCl in the new solution. Singayikhohlwa leyo ukuthi the concentration in the new solution. Kusale into engaka le kade ilento, then we find that what is now the new concentration ileyo in the new solution. Right. Sanibona ngiyaqala manje ngibheka one of the questions, examination type question is acids and base. Bajwayele ukukhuluma ngale acid engajwayelekile le. Ngithe let me do a problem kuyona ngayo le kwiza i-oxalic acid. I-oxalic acid yona empeleni COOH in brackets 2. So nansi futhi ibhala kanjena futhi as H2C2O4. So we have COOH in brackets 2 ibizwa kuthiwa this is oxalic acid. Now here they take 0.72 grams of oxalic acid. If you take 0.72 grams of oxalic acid and dissolve it in water and titrate it by dissolve engaka in water and titrate it. So which means in water bafake oxalic acid and then basically titrate. So we have usually we use volumetric flask, sifaka u-0.72 grams of oxalic acid. It's all right. So sifaka yona ke, and then base be titrator. So obviously uma you titrate a base, that is an acid, you titrate it against a base. Yiphi leyo base esetshenzisiwe? Sodium hydroxide ongakanani, 500 or 50 cubic centimeter. So the end point is reached by adding, which means the end point ilapha kuthola khona ukuthi all of the acid is being used up by a base, sodium hydroxide. So could reach an end point where sodium hydroxide react ne acid, oxalic acid. Then they say the acid-base reaction is represented by the following equation. Now looking at this, left base layer is 2 moles of sodium hydroxide, it reacts on 1 mole of oxalic acid. This should tell us something. With oxalic acid is diprotic. It donates ngabo hydrogen ababili la. In actual fact, structure sakhona se oxalic acid, you find something of that nature, then you have OH, then you have OH. So it donates ngalabo hydrogen ababili oxalic acid. So njengoba it donates ngalabo hydrogen ababili, then it gives us sodium. Sodium izongena lapha nakote khona hydrogen, then we call it sodium oxalate plus 2 moles of water. Now, a nice question, abantu sebe kremile ukuthi they will always say kuzoba naleya equation ukuthi ihamba kanjani leya equation. They will always say ukuthi hayi sazosebenzisa NA over NB is equals to CAVA over CBVB. Aye, asikafiki lapho. So but calculate the number of moles of oxalic acid used in the reaction. What do we know? Mesfuna number of moles. Number of moles, we know it is mass over molar mass. Number of moles, it's mass over molar mass. Mass oxalic acid, H2C2O4. So we want the number of moles that are in that solution of oxalic acid that was used for reaction. So mass is 0.72 grams. Then molar mass, I guess molar mass H2C2O4. Then what do we have? Molar mass, hydrogen is 1 times 2, carbon is 12 times 2, oxygen is 16 times 4. So we have 2 plus 24 plus 64. So we know 16 times 4 is 64. Then we will have what? 64 plus 26. Sithola 90 grams per mole. 90 grams per mole. Then we divide this by 90. So we say 0.72 divide by 90, and then we have Sitola, it's 8 number of moles, it's 8 times 10 to the power minus 3 moles. These are the number of moles that are in oxalic acid that were used for, this is 1.1. 1.1. Sengathi mina solution to the problem. So we get the solution to the problem. Then we have this number of moles that are used in the reaction. So 1.2, it calculates the number of moles of sodium hydroxide. It says there was a oxalic acid. Now they want the number of moles of sodium hydroxide present in 50 cubic centimeter of sodium hydroxide solution. Present in that 50 mesikhumbula ukuthi kwenzekeni na kule ya 50 neutralize yonke sodium oxalic acid. Sodium hydroxide neutralize yonke oxalic acid. So sifuna ukuchecka ukuthi ama number of moles angakanani aku 50 oxalic sodium hydroxide. Then we have 1.2, then sifuna sodium hydroxide, sifuna number of moles ukuthi mangakanani. Then siya kwi ratio lapha. From the reaction, we can say from the reaction ratio, 2 moles of sodium hydroxide requires 1 mole of oxalic acid. 1 mole of oxalic acid. This is true. 2 moles of sodium hydroxide requires 1 mole of oxalic acid. Therefore, siyawafuna ama number of moles esingawazi. Then therefore, X moles of sodium hydroxide will require how many are reactive? It's 8 times 10 to the power minus 3 of oxalic acid. These are the number of moles, the actual number of moles that reacted the sodium hydroxide, 8 times 10 to the power 3. Kodwa ziya ngaleyo ratio. Then you cross multiply and solve for X. So you have 2 times 8 times 10 to the power minus 3 is equals to 1 times X. 1 times X, 2 times that. So you cross multiply and you solve for X. So 1 times X is X. So 2 times, then we can say 2 times 8, okay, ngithola mina hawu bawethu yalula lento. Ngithola 1.6 times 10 to the power minus 2 moles. These are the number of moles of sodium hydroxide. Number of moles of sodium hydroxide. These are the number of moles, which is 2 times what it was. And this makes sense. 2 times, each time when 1 mole of oxalic acid reacts, we have 2 times of what it was, of sodium hydroxide. So which means if it's 2 times la, if it's 2 la, it's 4. So esikwenza la, ukuthola lokhu la, kumele si divide ngo1 ukuthola lokhu. Ukuthola lokhu kwala, kumele le si multiply ngo2. 1 requires 2, 2 requires 4, 7 requires 14, 3.5 requires 7, etc., etc. So this is how it goes. So we have 1.2 is nikeza leyo answer. Now let's go for 1.3. 1.3. And you need to be very careful. Bayithanda kwi-exam i-oxalic acid. They know ukuthi sifundisa kakhulu sulfuric or hydrochloric nani kodwa ke bayithanda i-oxalic acid kwi-exam. The concentration, calculate the concentration of sodium hydroxide solution Oh, concentration. It's in concentration now. Number of moles over volume. Mangakanani ama number of moles esiwatholile sodium hydroxide laphana sithole ama number of moles awu 1.6 times 10 to the power minus 2. Volume engakanani na 50 cubic centimeter to cubic decimeter 0.05 decimeter cubed. Divide by 1,000 when we convert cubic centimeter to cubic decimeter. So this is 0.5. So 1.6 times 10 to the power minus 2 divided by 0.05. This is 0.05. It is 0.5. Cha bobo. Nami kusho mhlambe imangivuka. It's 0.05. So we have that. Concentration is divide by 0.05. Then we have that. Concentration 0.32 mole per decimeter cubed. So we have 0.32 mole per cubic decimeter. So that is the concentration of sodium hydroxide. So be careful when you approach lama questions lawa, the examination type, please fundisisa isibala. Fundisisa ungavesene nje ubone igama nje asiyenzi ama ngesipuni bebethi i-begrip or i-comprehension ubone igama elithize. So simebebuza nje uthatha lapho nje soyabhala usafundi ne-question, funda la ukuthi bathi siku-calculator kanjani. So this is how it goes. Namhlanje we'll look at examination type questions on acids and base. The question lena engibhale lana, some of the things ngizozama ukuchaza nje at length, but kokunye nje so refer nje kule message kule lento kade siyenza ngaphambilini. Now here they say the labels on four bottles in the laboratory. Ngiyaqolisa ukuthi bottles is bottles. Mine is the bottle. Bottle. The labels of 4 bottles in the laboratory reads as follows. Number A is sodium hydroxide, 0.2 mole per cubic decimeter. Since by the mole per cubic decimeter, it means that is the concentration of sodium hydroxide. B is nitric acid, 0.2 mole per cubic decimeter. Nayo okusitshela ukuthi nayo it's a concentration is nitric acid. Carbonic acid, not carbonic, sorry, it's vinegar leyo. Ethanoic acid. Now concentration yakona is 0.2 mole per cubic decimeter, and ammonia concentration yakona is 0.2 mole per cubic decimeter. Now bayabuza ke 1.1, which of the above mentioned substances are classified as monoprotic? Monoprotic siyakhumbula ukuthi yile ekwazi ukudonate ngu-H plus owodwa bese kuphelele kanjani. It can only donate, that is a substance that can donate with one H plus, and then that's the thing, that's the end of it. So obviously number A is not an acid, it's a base, because as it dissociates it forms OH minus, and according to Arrhenius the OH minus ileyo substance, the base ileyo substance that forms OH minus when it dissociates in water. Let's see number B, HNO3. Oh, perfect. Number B, it's monoprotic. Number 3 is monoprotic because if HNO3 dissociates in water, it forms H plus aqueous and OH and NO3 minus aqueous. Or we can say, if we don't want to say H plus aqueous, we can say H3O plus. That is hydronium ion. This is H plus in water. Let me zoom. siyayizuma lento sesizuma sesizothi H plus in water that is aqueous we have H3O plus. That H ingene lapha emanzini yandisa inamba ka H and the charge, so it's hydronium ion. So whether you say H plus aqueous or H3O plus, you still mean one and the same thing. But don't say H3O plus aqueous. You must say H plus aqueous or H3O plus. Right. What about number C? Number C is also a monoprotic. Why? We know, we said before, H3COOH in water will also give us H plus aqueous and CH3COO minus. So it can only donate null hydrogen, not these. You remember I said these hydrogens are bonded to carbon, and the bond between carbon and hydrogen is very strong, so it won't donate with this hydrogen. It looks, mawibuga, in about hydrogen about 4, but when it dissociates, when it donates, it can only donate with 1 H plus. So this is a monoprotic. What about NH3? Oh, NH3, it's very impossible for it to donate hydrogen number. So our monoprotic acids, it's B and C. These substances, that is B, nitric acid, and ethanoic acid. Please pay a lot of attention to this one, because it donates with H plus or water lona, but not nalababu hydrogen abalapana. So it is classified as a monoprotic. So this is how we should look at it. But now when you answer it well, you can write all those stuff, but you say B and C, which one of B and C, but you must know what lawyer B and C. Let's look at number 2, 1.2. Write down an expression for a Ka value of these acids. An expression of a Ka value of these acids. Mesizokwenza ama K equilibrium. Mesikhumbula kahle. Mesizochecka lapana we'll be doing. We say Ka, it's what? It's concentration of products. It's a ratio between concentration of products as against concentration of reactants. Concentration of products as against concentration of reactants. Let us look at the first one, HNO3 in water. Once it reacts with water, it forms what? It forms H3O plus plus NO3 minus. Now what is the expression for Kc of this one? We know that Kc in this case is Ka because it's constant of an acid. Ka is concentration of products as against concentration of reactants. Concentration of products as against concentration of reactants. So what is concentration of products? It's H3O plus concentration times NO3 minus concentration over reactants. It's HN concentration of NO3, HNO3. I hope yabonakala lapho, HNO3 and H2O. If H2O is a liquid, we don't include that. But if it's a gas, if we assume it's a gas, then we can include that. So but we have to write it like this. So this is 4 number B, for number B, that is an expression for Ka value. Now they say, write down an expression for Ka value of these acid or acids. Yabona ke? Nwena ke uthola ama acids awu-2, so it must be 2. So lo S lo benzela khona ukuthi muthole yodwa awubhale yodwa phela kodwa empeleni zu2. That is why bathe acid bathi mhlawumbe acids. So with us it's acids. Yiphi enye acid na? Number C. Uthini number C wethu na? It's CH3COOH plus H2O. It forms H3O plus CH3COO minus. What is an expression for Ka? Ka says bonile. What is its concentration of H3O plus and CH3COO minus. These are products over what is a constant reactants. It's concentration of CH3COOH as times H2O. We know the conditions of putting all these using the law of mass action. We'll come back to that one as we do rates of reaction and chemical equilibrium. But this is how one should write the Ka value for 1.2. Then we go to 1.3. Susutsela 1.2 sesiyahlupheka kuhle njengoba noma ngisusa ngeke ungistop uthi hayi bengisabhala wena uzorewind nje ubheke futhi kabusha kube mnandi ungathi hayi awenzani lo awenzani ngisabhala hayi wena uzorewind laphana kwi-cellphone yakho. Hayi uma ingekho ke lapho rewind khona aseyofuna uyothenga entsha yini na i-cellphone. What is the difference between a strong acid and a concentrated acid? A strong acid yileyo substance that dissociates almost completely in water. That is a strong acid. If you take a substance that dissociates almost completely in water, one of the products may say dissociate almost completely, it forms H+. That's a strong acid. For instance, HCl is a strong acid. Ngoba to HCl emanzini in water, it dissociates H+ aqueous and Cl- aqueous. Or we can say HCl plus water, it forms H3O plus and Cl- aqueous. So we have that we have HCl in water, so it dissociates completely. Then that is a strong acid. Any substance that when it dissociates in water, it forms H+ as one of the products and the other ion, but it dissociates completely. That's a strong acid. But what about a concentrated acid? A concentrated acid, it's any substance that is more, it's more of itself, that substance that can form H+, but iningi ukudlula is solvent. Yeah, it's more than amanzi. In this case, we use water as solvent. So if you have a high concentration of acid, which means it's more than its solvent. So iningi yona ukudlula lento eyihlakazayo. So that's a concentrated acid. So we can still have a weak acid being concentrated. We can have a strong acid being concentrated. We can have a weak acid being dilute, a strong acid being dilute. But in our case, we have a concentrated acid is that substance that can form H+, but where it's more of that substance more than a solvent. In our case, we use a solvent as water, so it's high in volume than a solvent. So that is a concentrated acid. 1.4. Which of these substances has the highest pH value? Highest pH value. So if the pH value is high, obviously lower acids lower, the pH value is low. Acids is less than 7. But look at number A, sodium hydroxide. It forms OH minus. So if OH minus are produced in the solution, then that OH minus increases the pH value. So it becomes more than 7. So sodium hydroxide, we know, sodium hydroxide, let me write it there, ukuze sikhumbuzane, theorize. Sodium hydroxide in water, it forms Na plus aqueous and OH minus aqueous. So we have seeing that this one forms OH minus. This increases the pH. As we have more OH minus in the solution, then the potency of hydrogen becomes more. So the pH is high. So this number 1.4, the one with the highest pH value, obviously is sodium hydroxide. 1.5. Sihlabela mgama, asho njalo amaXhosa athini na, sihlabela kuphi na? Mgama, hayi kagama kodwa kuphi? Mgama. 1.5. Consider compound A if it dissociates completely in aqueous solution, right? Yeah. 1.5. Consider this if it dissociates completely, it dissociates in an aqueous solution, it forms that. Oh, but wait, consider that if it dissociates completely in an aqueous solution. Determine the concentration of hydroxide ion. What is the concentration of OH minus? Ingakanani on the concentration of sodium hydroxide? Sodium hydroxide 0.2 mole per cubic decimeter. Oh, if one produces 1 and 1, OH manje. If one produces 1, so 0.2 mole per cubic decimeter will also produce 0.2 mole per cubic decimeter. But the ratio is the same. 1 mole of sodium hydroxide produces 1 mole of OH minus. So 0.2 will give us 0.2. That is the concentration of OH minus. So we have this. So Augustella, the concentration of OH minus is 0.2 mole per cubic decimeter. Right. Now, calculate. Consider, determine now the concentration of hydronium ions. The concentration of hydronium ions. Let's work it like this. We know that the Ka value here too it's 1 times 10 to the power minus 14. So what is 1 times 10? 1 times 10 or 10 to the power minus 14 is equals to concentration of OH minus times concentration of hydronium ion, or it can be H plus aqueous. H plus aqueous. Motada, you can use that or that one. Then what do we have? We have, what is concentration of that? 10 to the power minus 14. It's our constant value. Then what do we have? OH minus is 0.2 times concentration of H3O plus. So I guess check it. We have concentration of H3O plus, hydronium ion, abanye bathi oxonium ion, abanye bathi hydrated hydrogen. Then we have 10 to the power minus 14 divided by 0.2. What do you have? What is concentration of hydronium ion? Let's check lapho. Sitholani na? 10 to the power minus 14. Ngithola la 5 times 10 to the power minus 14. 5 times 10 to the power minus 14 mole per cubic decimeter. That is the concentration of H3O plus. Oh, let's go with the sky. Okay, so that is the concentration of H3O plus. So this is how we got the answer. The pH of the compound. What is the pH of the compound? The pH it's minus log the concentration of H3O plus. So minus log the concentration of H3O plus. So a pH is 13.30. That is the pH. Yayibona ke ukuthi inkulu kangakanani pH yakhona 13.3, which shows ukuthi it is the substance that has a highest pH value 13.3. Niyazi phela pH ranges between 0 and 14. So we have this 13.3. 1.6. Which solution will react to form a salt with a pH which is less than 7? Yipi solution that can react to form a pH which is less than 7? Form a pH which is less than 7, which means that pH, that solution will be acidic. It will be acidic. Which solution, which two solutions will react to form a salt with a pH which is less than 7? Two solutions, obviously. Lena will react to form ngoba izonikeza OH plus kwi solution. And then what about ammonia? Why not this one? This one, acetic acid, it forms CH3COO minus plus H plus aqueous. Acetic acid in water, it gives us acetate ion and COO minus. But now the problem comes if acetate ion in water, it's a strong conjugated base of a weak acid. So mengena solution that acetate ion is in water plus H2O. It's a strong conjugated base. It will readily accept H plus. It will take H plus because it's a strong conjugated base. It will take H plus from water. Bese isakhela nina CH3 COO H. You have to H plus from there. Bese kusala kuyini OH minus. So ukwakheka kwa OH minus iyokwenza ukuthi the pH ibe greater than 7. What about NH3? NH3 uma ingene emanzini NH3 will readily it will act amanzi will accept will donate H plus to NH3 to give us NH4 plus what? Plus OH. In fact, NH3 is a stronger acid. I beg your pardon. NH3 is a stronger acid. It will donate OH plus emanzini. Then it will form NH2 plus, NH2 minus, and then we'll have H3O plus. So the two salts that can react, the two solutions that can react to form a salt of pH less than 7, P, it's NH3, HNO3, it's P, and our D, P and D, these are the solutions that will give us a low pH, a pH which is less than 7. It cannot be this one, but this one, as ngikhombisile, izokwenza ukuthi solution then we'll have HNO3. But if it's ammonia in water, ammonia will donate with H plus, then a lot of hydronium ion will be formed, hence decreasing the pH of the solution. So it's P and D. I guess 1.7. Let's go to 1.7. Now they say, assume for 10 cubic centimeter of A, skulmang A, 10 cubic centimeter of A, concentration of A, or volume of A is 10 cubic centimeter. Assume that 10 cubic centimeter of A, we know the concentration of A, is 0.2. You take this 0.2 mole per decimeter cubed. So we have 10 cubic centimeter, and a concentration of 0.2 mole per decimeter cubed, and is diluted. You dilute that to 30. Then now we say VA again. Let's say Lana is before dilution, and then what about after dilution? After dilution is diluted by kubanisa namanzi bese iba ngakanani na iba 30 cubic centimeter. Determine the new sodium hydroxide concentration. What will be the new concentration? Now listen to this one. We know before dilution, njengoba sine concentration ka A, volume ka A ne concentration ka A, which means sinama number of moles ka A, our concentration ka A ne volume ka A, ama number of moles ala. But listen to this one. The same solution by dilute. Maybe dilute kushintshe i-volume. Mokushintsha i-volume, in concentration izoshintsha, as long as the number of moles remain the same. Why do we say they will remain the same? Ayikhishwanga leyo solution ku-add nje amanzi, which means ama number of moles ala is the same number of moles alaphana. Ayikhishwanga leyo solution. Okwenzekile nje kuleyo solution yayilapho kuthelwe nje amanzi yadilutwa, okusitshela ukuthi ngale nkathi volume iba more. Look at the relationship C and V. If the volume is increased, sesilindele concentration should be less than 0.2. ngilindele lokho nami ngoba ngiyazi ukuthi uma ku-equation i-relationship is like that, multiply the two. If one of them increases, the other one decreases. They are inversely proportional, provided this is kept constant. And obviously, our number of moles of acid now is kept constant. Now, ngoba the number of moles of acid yala is the same number of moles of acid yala. It's number of moles of acid, number of moles of A, sorry. Number of moles, this is volume of A, is not acid, but wait, volume of A, concentration of A. Volume of A, concentration of A. So number of moles of A yala is the same as number of moles of A yala. Then what do we have? We'll have CaVa. We equate the two. Will be, this is before dilution, then it's CaVa after dilution. Very tricky question, but wait, after dilution, very tricky question. Ungayi ngobuso, ungabuya ungesenabo unina ubuso. So we have CaVa. So what is Ca? Is 0.2 times 10 is equals to Ca after dilution. Sifuna yona Ca after dilution times volume 30. Then what do we have? We'll have 0.2 times 10, which is 2 divided by 30. That is concentration of the acid, of A, of sodium hydroxide. So what is concentration yala? Then what do we have? 2 divided by 30. So we'll have something like 2 divided by 30. Let me not 2 divided by 30, then I get 0.0667. So, which is concentration of solution A, it's 0.0667 mole per cubic decimeter. That is the concentration. The concentration has decreased from 0.2 to 0.0667 mole per cubic decimeter. Then Babu Zabati, and hence predict with reason whether the pH will increase or will decrease. If the pH, if the concentration is sodium hydroxide, we need to predict now. If the concentration of sodium hydroxide becomes less, it means less OH minus are formed. If less OH minus are formed, then the pH will go down, or more of H plus will be produced. So as we know that as the concentration, this being a base, as the concentration of the base decreases, it means less amount of OH minus, and if the OH minus in the solution decreases, then this decreases the pH of the solution. If more OH minus, if our OH minus baba more in the solution, then this increases the pH of the solution.